இது ஒன் மந்த். இது ஒன்றும் இது வரல, ஆடியோ வரல.
இல்லை யாரும் எதுவும் பேசல சார்.
யாரும் வரலையா உள்ள?
வந்து சரி சார் பார்ட்டிசிபேட் பண்ணுங்க.
சரி, பேசலாம், நான் சொல்கிறேன். அதை பற்றி ஒன்றும் இல்லை.
சார் சிப்ரா சார், அவங்க பேசுகிறது ரெக்கார்ட் ஆகுதுங்க. அவர் மியூட் பண்ணு, சார் மியூட் பண்ணு.
இந்த அட்டல் லிங்க் இருக்கு இல்லையா, அது பிளாக் பண்ணி வச்சிருக்காரு, அந்த எடுத்துக்க சொல்லுங்கள் சார்.
என்ன சொல்கிறது? பிளாக் பண்ணி வச்சிருக்காரா?
அது வந்து யாரும் அவங்க போஸ்ட் பண்ண அளவுக்கு பண்ணியிருக்காரு.
ஆமாம்,
அது வந்து ஓப்பன் பண்ணி சொல்லுங்கள்.
ஏன்
அவர் எதை போஸ்ட் பண்ணணுமா ஸ்டாஃப்? அதுக்காக
என்ன போஸ்ட் பண்ணோம்?
அதாவது வேணும்னா இப்போ சொல்ல, இப்போ வாட்ஸ்அப் காலில் பண்ணுறாங்க,
9 அனுப்பிட்டு இருப்பாங்க, அதனால் கட் பண்ணிட்டு இருக்காங்க.
ஆமாம்
சார், அந்த இதில் அட்டலில் வாட்ஸ்அப் குரூப்பில் பிளாக் பண்ணி வச்சுருக்கீங்கல்ல, மெசேஜ் போடாமல், அது வந்து எடுத்துட சொல்கிறாருங்க சார். ஜி ஏதோ ஃபேக்கல்ட்டிஸ் எதுவும் போடுவாங்க. இது இன்றைக்கி மட்டும் எடுத்து விட்டு அதுக்கப்புறம் லிங்க்கை ஷேர் பண்ணிவிட்டு மறுபடியும் க்ளோஸ் பண்ணிடுவோம். ஓகே சார். சார் லைவ் கனெக்ட் ஆயிடுச்சு. லைவ் கனெக்டட்.
Professor Manikandan?
Yes, sir.
How about Dr. Shiva?
Sir, he's coming, sir. Come. Sir, hello, sir.
Whether he has joined?
Yes, sir, joined, sir.
It's 10. Would you like to wait or would you like to just initiate?
Sir, we shall start, sir.
Yeah, you check with Dr. Shiva and our chief guest, then you can.
Okay, sir. Okay, sir.
Yes, sir. Sir, am I audible?
Yes, Dr. Shiva. Yes.
Yes, sir. Very nice to see you. Good morning. Manikandan, would you like to start with your forward?
Okay, sir.
Yes.
Oh, thank you, sir.
Dr. Manikandan, kindly check with our chief guest officer.
Yes, sir. Sir, he is available, sir. He is in the. Hello, sir. Somnath, sir. Hello, doctor. Somnath, sir. Hello. Hello. Hello, sir.
You can wait for another 1 or 2 minutes.
Okay, sir. Okay, sir. Okay, sir.
Hello.
Hello, sir. Hi.
Mm-hmm.
Good morning, sir.
Good morning.
Sir.
Yes, Professor
Very
Manikandan.
short. Yes, very short.
You can commence, yes.
Okay, sir. A very good morning to all. I am Dr. J. Manikandan, Professor in the Department of Mechanical Engineering at Hindustan College of Engineering Technology, Coimbatore, and I am the coordinator of this program. First of all, I like to thank AICT Training and Leading Atal Academy to sponsor for this 5 days faculty development program on additive manufacturing. I take immense pleasure in welcoming our chief guest, Dr. Somnath Chattopadhyay, Associate Sir in Mechanical Engineering. Dear participants, I hope that this session will be very informative and interactive. So I request all the participants to utilize this program and make the event in grand success. Now I hand over the session to our beloved head of the department, Dr. K. Siva, to give the welcome address. Please, sir.
Good morning. Respected CEO, sir. Respected speaker on the occasion, Dr. Somnath Chattopadhyay, Coordinator Manikandan, dear faculty members and participants from various institutions. It is very nice to have a topic on latest technology, that is additive manufacturing, which is quite interesting also. 3D printing is a dream come true. In that topic, we are going to conduct AICTE sponsored FDP. It is a good occasion for us. I can say that it is a brainchild of mechanical engineering, this particular concept. Solid modeling. That is the mainstay of, that is something having layer by layer deposition, which is a mainstay in solid modeling, which is the concept that has been driving in additive manufacturing. And we know that any complicated object which you want to make can be created with a CAD model. That is going to be an easy task for a mechanical engineer. And that CAD model, in a de facto file method, it can be stored in STF format, stereolithography format, and any problems in that has been rectified. And the new format, that is additive manufacturing AM file format, came. And even if there are errors available, then how it is going to be rectified through slices software, and finally how the G code is generated. It's all a complete package. And finally, we are getting a great outcome. A project of any complexity is going to be made through 3D printing. There are many challenges available in 3D printing. We all know how the repeatability has to be obtained again and again. The precision has to be there. Material usage is a big challenge because we know when we go for 3D printing, we need to depend on a single material, but in objects, we want various materials to be joined and made. But additive manufacturing has given a new hope in the form of using even metals in ceramics. But still, how in a combined manner, different materials can be used for depositing and creating models. It is really a big challenge. Earlier, we thought 3D printing is only meant for polymers. That is the idea that is available with everybody. But even with metals and ceramics, how we are going to make the models, it is quite different with additive manufacturing. We have got a footage in this. We started RPT lectures in the year 2013. We brought people from multimedia, Anna University. That time, the director, Dr. Gauri, was there. He was coming here and he was conducting a one-day workshop on rapid prototyping. We know rapid prototyping, how the functional and aesthetic models can be made. But the very improved methods have come in the form of additive manufacturing now. And in this journey, we have gone for even purchasing a 3D printer some 5 years back. And we found some interesting good models can be created with the help of our 3D printer. We in our campus, in our department, we go for participating in design and fabrication of all-terrain vehicles for our students. The all-terrain vehicles, we make models, and those models were taken for visual presentations. We used to go for first round of competition, that is visual presentations. It is a very tough one. The students are used to even make some 80 to 85 slides. Along with that, they used to take a small prototype of the car which we are going to make. We suffered a lot. We joined the small plates, small wheels, and we could able to fabricate small vehicles. It took time for us. We went and participate in visual presentations, which is the very beginning of all of our all-terrain vehicle competitions. We suffered a lot in that, particularly in terms of more time consumption. But later, when we bought our 3D printer, it became so easy that within hours we could able to make the models, provided we understood how some small support frames can be given and overhanging frames can be supported, how such kinds of models can be created, and later how those small supports can be taken off or it has to be dissolved. We learned a lot in that process. It is quite interesting to always work with a 3D printer. Even after that, we went with MOU with some of the major manufacturing industries, foundry industries. We had some preliminary talks of how a combined 3D printing setup can be made and how the jobs can be created. We went with some beautiful ideas. We had some first rounds of talks also. And later we made a center of excellence in digital fabrication in our department, and that is also a quite good concept where we can make models through CNC, and then we can make models through the printer. We have quality checking through TMM, a coordinate measuring machine. This combined form of digital fabrication lab, which is taken as a center of excellence. We actually did this with a company called SVP Lasers. This is also a good concept, a good idea. Students can find lots of activities in this with the 3D printer. So this also we tried. It is also going on. So it is because if you see the applications of 3D printer, it is going to be very extensive. There are numerous applications available, right from biomedical, the prosthetic limbs can be made nicely, and the aerospace, even the fuselages, the fans which can be made out of that. Even recently, I heard that NASA is trying to make food from 3D printers because the wastages can be very minimum we are going to print the food items which are needed for the astronauts. And also they see that for the exact dietary needs of astronauts, how much quantity of food is to be taken, and how the wastages can be left out, and how it can be optimized. So in the food industry also, we can see the 3D printers are very much useful. So it's a very interesting field where we could be able to get this chance. I am really thankful to Atal ACTE, because they understand the needs of the society now, the needs of the industry now, how we have to grow in this new technology, which has come from our PTA, has come to a nice stage. So I thank Atal on this occasion for sanctioning the fund for us. I thank the various speakers who have accepted. We are bringing speakers from the companies like Insta3D, then from BHP Kaifac Core. Professors are coming from VIT, SRM, NSS Kerala. Even a professor is joining from Royal Melbourne Institute of Technology, Australia. So we have planned nicely. The schedule is going to be very nice for all of you. Even there is a session for stress management, and there are going to be speakers from healthcare units. So the participants are going to be really enjoying all the sessions. So with this few words, I welcome our respected CEO sir, a very dynamic person. He gives complete freedom to all of us. He encourages all of our activities. I welcome you, sir. I heartily welcome Dr. Somnath Chattopadhyaya, Professor Mechanical Engineer, IIT Bangalore. Welcome, sir. Welcome to this.
Thank you very much.
DP. I welcome all the participants. I congratulate the coordinator. I welcome all faculty. Welcome all of you.
Thank you, sir, for your wonderful speech. Now, I invite our Chief Executive Officer, Dr. K. Karnavaran, Hindustan Group of Institutions, Coimbatore, to give the presidential address. Sir, please. Sir.
Vanakkam, and very good morning to all of you.
Good morning.
From the desk of the management of Hindustan College of Engineering and Technology, I would like to extend my warm greetings and good wishes to every one of you who have joined for this ICT's Training and Learning Academies Faculty Development Program on Additive Manufacturing, arranged by the Department of Mechanical Engineering under Hindustan College of Engineering and Technology. Friends, I would like to just start my small speech with Dr. Abdul Kalam's quotes. We all know that one of the quote which is very much suitable for the higher education sector. I would like to just bring that quote just for sharing with all of you. Quote begins: learning gives creativity. Creativity leads to thinking. Thinking provides knowledge. That knowledge makes anyone great. We do this process in our higher education institutions. We teach and we expect our students to learn. In the process of learning, those two components are getting in: creativity and the thinking process. Only by allowing a mind to think and create, then only there is a possibility of knowledge acquisition. We all know that. Being a professor in mechanical engineering or in any engineering college, simply teaching will not provide knowledge to the student community. We all know. So we have to keenly design our whole system to see that whatever they learn, they put into practice. That leads to both creativity component as well as thinking to the minds, young minds. Probably that alone will lead them to be a knowledgeable person. So we are in the committed process of knowledgeable society in India to all our institutions. Friends, with a very clear vision, initiate, inculcate, and innovate. Hindustan Group of Institutions in Coimbatore established 11 institutions. One of the institutions is Hindustan College of Engineering and Technology, started in the year 2000. It's a 20-year-old institution, accredited with the A grade by NAC. 5 of the departments, including the mechanical engineering departments, are accredited by NBA. Rated very well, and strong R&D base is existing. We have around 5,000 plus students study in this institution, over about 300 faculty, and many research departments are also existing. It's a very innovative curriculum. Being an autonomous institution in the last 5 years, we have been really focusing ourselves towards the future needs. We commit ourselves to create future leaders from our campuses. We strongly believe that the curriculum system or the college process is not only for employment. We are committed to develop the other skills also for our student community, whether it is humanistic knowledge or meta knowledge. So we never stop with the fundamental knowledge, whether it is mechanical engineering or electrical engineering or IT areas. So this college is offering variety of programs. We offer 15 different programs, starting from core engineering to specialized engineering and the recent newer technology like AI and agri engineering, biomedical, whatnot, everything is there. So now we are establishing some interdisciplinary center of excellences. And I know the footage of mechanical engineering into the field. I must appreciate at this time the work done by the head of the department, Dr. Shiva, Professor Manikandan, and all the faculty members working in mechanical engineering department. One of the core strength of this institution is from mechanical engineering. So my appreciation to the entire community who are affiliated to mechanical engineering department of Hindustan College of Engineering and Technology. Coming to the topic, additive manufacturing. Friends, AICT is pushing in the recent past, particularly in the last about 3 years' time. They have come up with a lot of schemes. One of the schemes is now Atal. AICT is strongly believing that until otherwise we equip the teachers, we cannot make worthwhile graduates out of our campuses. That's the reason AICT has come out with a lot of schemes, many schemes in the recent 3-4 years' time. Whether it is STTP or FTP or the other hackathon kind of things, or Institution Innovation Council, all those things are now in place. And yesterday, I think you could have watched the session by the chairman of AICT, addressed to all the principals and the stakeholders in the country, giving way forward towards national new education policy. So AICT is coming with a major revamp in its own system, aligning with the expectations of NEP. So we can expect major minor papers hereafter, and plenty of flexible models into the system. Almost all the institutions will enjoy their own autonomy. Fine. So this is in the case of AICT. Coming back to additive manufacturing, I know that mechanical engineering is the base for all the other engineering branches. Until otherwise we properly design, manufacture, and come out with the quality-oriented process as well as products, we cannot take it to the market. Whether it is for aerospace engineering or medical engineering, wherever the applications are going to be there. So the role of mechanical engineers, production engineers are the key people behind all the innovations which we intend to develop in the arena of engineering technology. So once again, I would like to appreciate and congratulate Professor Manikandan and Dr. Shiva for arranging this program with the help of AICTE's. Joining from IIT Dhanbad, the Associate Professor of Mechanical Engineering, Dr. Somnath. My greetings once again to participants and my dear friends. Thank you so much for the great opportunity. Over to Professor Manikandan.
Thank you, sir, for your valuable speech. It is a great honor for me to introduce and welcome our chief guest, Dr. Somnath Chottapadhyaya, in this morning. He has received his B degree in production engineering from Janmanpur University in 1992. He did his M.Tech degree in mechanical engineering from IIT ISM in 1999 and a PhD degree in production engineering from BIT ISRA in 2005. He is presently working as Associate Professor in the Department of Mechanical Engineering of Indian Institute of Technology, Indian School of Mines, Dhanbad. He is the author of 61 articles in SCIE category journals and guided 10 PhD scholars, leading to their award of the degrees. He is also the author of 5 books and 3 book chapters. He was the recipient of 2 Best Paper Awards in international conference held in Europe in 2 occasions. He has 8 years industrial experience and 21 years of teaching and research experience. He is also principal investigator and the co-principal investigator of some projects from AICT, UGC, Ministry of Power and DRDO, etc. Now I hand over the session to Dr. Somnath Chottapadhyaya. Please, sir.
Thank you very much, Professor Manikandan, respected Professor Karunakaran, respected Professor Shiva, and definitely all the organizers to give me the opportunity and for the nice introduction. Now I want to share my screen. Yes, and I will go to my slides and then I will start the discussion. Is it visible to everybody?
Yes, sir.
Thank you very much. So the listeners also from the colleges, am I audible to you and my screen is visible to them?
Slide
Okay. Audible also?
Yes, sir.
Fine. Thank you very much. So our topic is today hybrid additive manufacturing. Though it can be the last topic of the additive manufacturing, but I start with some kind of, say, reverse engineering so that people can get some idea about what is going to happen here and maybe in the different parts of the world related to the manufacturing. But very, very interestingly, I'm very grateful to Professor Karunakaran. He is singing the success songs of mechanical engineering, definitely, because everything has to be executed in the deliverable form. And mechanical engineering means you can grasp the thing. So mechanical is associated with that. And just to tell about the Latin word meaning of manufacturing, it is coming from the word manus plus factus. Manus means by hand and factus means that produce. So manufacturing means in 15th century produced by hand. And today's manufacturing is anything manus plus factors that is produced by hand. But still people are sticking to the old terminologies because in most of the before industrial revolution, the entire part is manus plus factors produced by hand. So here we'll be discussing about, as it is very, very nicely presented by Professor Shiva, what is the role of additive manufacturing. Truly speaking, nature believes in additive manufacturing. We are formed in the wombs of our mother through deposition. and this is additive. Though my stalwart professors are experts in metal cutting phenomena, but still they have to admit that additive manufacturing, the deposition one, is the most important one, and nature practice that, but only few differences are there. So nature, whatever they do it in a monolithic form with protein and other part of it. So it is protoplasmic. It can produce one after another, just like Robot by Karl Kapek of Czechoslovakia. He has proposed the word roboti. That means it can produce all those things. These slabs, it can be produced by itself, and it is auto-adaptive. I'm not going to that definition because that will be tomorrow's mechanization or automation. So here we'll be discussing about the manufacturing and hybrid. Why it is hybrid? Because additive as well as subtractive. Additive definitely, but there are little issues and hassles, so that can be taken care of by subtraction. So subtraction as well as addition in terms of the rapid prototyping environment lead to the complex production of all those kind of feature-enabled product. We are not interested only in the simple product. We are associated with feature-enabled product. And why 3D printing is relevant? It is just like a trump card. Because in the conventional manufacturing or the subtractive manufacturing, we use the machine tools. What is machine tool? Machine tools are those machines which can manufacture some part of a machine. By some part, still in hardware form, we are unable to manufacture a machine which will produce itself. But in the virus, in the software, yes, we can make it out. So I always consider virus is the biggest creation of human being in terms of the software. So that a software program which can produce itself. But in mechanical engineering, still it is a distant reach. A machine can perfectly produce itself in totality. So that is why the definition of machine tool is limited to that. It is only can be capable of manufacturing a part of a machine. But problem with the conventional machine tool and metal cutting industry is that we require different kind of machines for different kind of geometric features. For the cylindrical surfaces, we employ layer, flat surfaces, we can employ shaping and painting, and maybe better surfaces in slab milling, then finer surfaces in grinding, and then finer surfaces in super finishing, lapping, and polishing. So just like a good batsman, we have to classify the deliveries, and according to that, we have to select our shots, and that makes the life very complex. So additive manufacturing or 3D printing and other thing is a panacea. What is panacea? A cure to all diseases. So it is a cure to all sorts of geometrical profile. Even a child, if these CAD model and other things are there, he can print it out without botheration of the different machine tools for different features. So it is an unique solution. So that is why we are so addicted, so carried away by the 3D printing process, and that is nothing but the additive manufacturing. So what is hybrid? Till date it is known as the object-oriented combination. Object-oriented combination, we are very much familiar with the object-oriented languages and all those things, where we have transformed from character user interfaces to graphics user interfaces, so that we don't have to remember the commands with the prints. We see the picture, icons, and according to that we click it out and we get it. So that is the object orientation, and that is introduced by Microsoft. But I am very happy to tell that some of my professors, Gopal Chandra Sen, Professor Gopal Chandra Sen and Professor Amitabh Bhattacharya, they are the leading people in terms of the machine tools in the world. They have introduced, mainly Professor Gopal Chandra Sen has introduced the iconic representation of the machine tools in his famous book, Machine Tools. Though he has written it for the diploma holders, but it is equally textbook all over the world and all over India, as to represent all those machine tools in icons. Much before Bill Gates has introduced those icons in the computer softwares. So iconic representations of all these things, and object orientation mechanical is leading the way. And why laser? Because laser is a champion material. Laser is like Ravichandra sheet. It can some background noise is coming. I request mute the background noises, please. Professor Manikandan.
Professor Manikandan, if you have control, can you mute Madam Rajamani?
Rajamani, please.
Can I continue?
Yes.
So, I have told that object orientation is very important. So why laser? Laser is a champion strategy. Just like he can bat, laser can cut, laser can measure, laser can join, and all sorts of things. And laser can do very precise operation. Little technical hassles still there in laser because laser cannot generate till today huge amount of power. So we are only limited to 20 watt, 30 watt, 40 watt. So that sometimes limitation in terms of dealing with higher material deposition or higher material removal rate and the joining of thicker plates. So that is still the technical hassles, but otherwise laser can be used for everything. It is just like a trump card in terms of joining as well as cutting, measuring and aligning, all sorts of things. And associated with the CNC operation with a single machine environment, we are looking for again a universal machine which can join, which can deposit, which can cut, which can measure, which can inspect, and all sorts of things in one single environment. And with a few comments, we can change all those things. That was first designed, and these kind of concepts were invented in Czech Republic, Czechoslovakia. The Prague is known as the machine tool capital of the world. So they have come out with some kind of Granovskis and other kind of classification. And that is why Adolf Hitler was very, very interested to take care to acquire Czech Republic, Czechoslovakia, in order to take control of all those components for his World War II. But it was not a successful attempt for a sustainable basis. So the laser cladding, CNC operations and all those things are implemented in a single machine environment, and that can be a very good measure or tool or strategy for hybrid additive manufacturing. So this manufacturing has attracted a lot of attention over the past half a decade, and so, but it is still in its infancy with a lot of technological hiccups that have to be adroitly addressed, because there are uncertainties, because a road to success is always under construction. So hybrid additive manufacturing strategy is under construction because a lot of things has to be taken care of, because many complex things has to be built into one machine tool so that everything can be done in different commands. So it refers to a new class of machine tool, and not the ordinary one, that brings additive metal deposition. Because already told that yes, rapid prototyping has been now slowly and steadily transforming into rapid manufacturing. It is not only the prototypes, even the parts and components, and very, very costly cars like Porsche and other car at Mercedes-Benz parts are to be printed and immediately we can put forward. And even for the space technology, where the spare parts management and other things are a very big issue. You know, very recently China has entered again their space vehicle into the orbit of Mars. So it will be a very regular phenomenon. So even not as gold is shortage, is of shortage. I think Nico is coming. Shortage, then there is no other way to send it from the surface of the earth. So one has to print it out, and print it out for actual operation, not just as a prototyping one. So deposition nozzle capability of the latest three-dimensional printing in the metallic environment with the access control and metal cutting capabilities, because metal cutting is the intended removal of material, and where is the unintended removal of material? Still dead. for the finishing and of high quality feature oriented, still we cannot subtract the subtractive manufacturing. Still we require some kind of machine tools which can take away the material. So along with the deposition, we have to do some kind of post-processing in terms of material removal. So we need CNC 5-axis type of capabilities in modern machine tool to implement for the final product. And this combination means that metal deposition can be performed along with the various axes. Total axis control is required in order to remove the material from already deposited parts. So all sorts of things will be implemented in the hybrid category. So the 3D printed material can be machined to precise tolerances. Tolerances are becoming very, very narrow and the margin of error is high. So at any stage in the process, even going back and forth between metal deposition and metal cutting as and when required. Sometimes we are positive, sometimes we are negative. Positive means we are depositing the material, negative, that means we are removing the material, and that has to be done in a single machine. And this adroit combination of additive and subtractive manufacturing is the basis of the term hybrid additive manufacturing. So additive plus subtractive is combined. You can see these are the features. We need these kind of product. We will fundamentally change the precision of manufacturing components. We have to make some kind of rope, just nanocarbon fibers. And nanocarbon fibers will lead to the manufacturing of the material which is having more strength to wet ratio, 100 times than that of the known steel. And if we have these kind of nanofiber based composite material, then we can have a rope to the outer space so that instead of throwing those satellites by the launch vehicles, it can climb like a spider to this rope. So everybody, 700 billion citizens of the world, maybe say half a century or less than that, will have these own independent satellites. No monitoring and no problem with the network related issues. Today we are telling humorously, it is not an official statement, Bhai Saab, BSNL means Bhai Saab nahi lagta. But sometimes people are telling Google se bhi nahi lagta. So these kind of network issues, another part of it, will be just eliminated if everybody is having his own way of satellite. And that is only possible because satellite launching cost is very, very great. So if we can have this nanofiber composite material with a rope to the space station, so our individual satellites will climb there and no issue, 7 billion satellites are there individually taking care of that. So whenever we want to impose all those things porosity, who is the master of teaching manufacturing? One of the masters is bees, honeybees. From the honeybees we can learn many lessons. First of all, they can have a vectorial tensorial dance through which they can communicate with each other that how far, what quantity, what direction, what kind of possibility of the honey is there in the flowers. They do a very complex tensorial dance. What is scalar? That is only on one value measurement. And what is vector? Direction and magnitude. And what is tensor? Direction, magnitude, and plane. So honeybees, through the dance, they can have a tensorial representation of all those things. Even before the advent of the calculus and other things, honeybees know these things. Another terrific thing is that honeybees, they can have these honeycomb structures. They can immediately, within 24 hours, they can shift the entire hanging structure from one place to another. And those honeycomb structures can give very high strength to weight ratio with the kind of porosities. So we have to learn from these how to deposit those blocks in such a very fashion you can make them all those things. And still there is a challenge. And sometimes one can feel that human being is in its infantile disorder whenever to compete with the best patients of all those hands and every.
Sir, hello? Hello? Sir, voice break. Hello?
I have to quote from the literature. Literature people are very, very intelligent. They can see the world with a vision, and that is no other than Pablo Neruda. He said, give food to the people who are hungry and give hunger to the people who have food. That is the assignment problem in case of all these politicians. Poverty, hunger is created by the politics. So he has said that give food to the people who are hungry and give hunger to the people who have food. And that is true for manufacturing. Deposit the material when it is survival and not be credited. Don't deposit the material. Type of design. I will consider it as online design. It is not an offline. We have online classes in COVID and other part of it, but I always promote that online design. Design should not come only that you are just, and then is the great design. Is offline design, but nature believes in online design. I will give you some example. And only hybrid additive manufacturing. These kind of situations can enable us to go for these kind of systems. So this powder deposition, the conventional additive manufacturing powder deposition process allows one place of material in the desired composition exactly where one wishes to have it. Pablo Neruda rule: deposit the material when it is required. Don't deposit it when it is not required. Powder deposition will enable us to do that. And one can manufacture the things which are impossible to make the other way, including internal voids, waves, honeycombs, lattice. Now, a lot of people, even my friend, he is there as a professor of University of Salerno, Italy. He is manufacturing all those artificial knees and limbs, and mainly the he's telling that hip replacement and hip replacement, if it is implemented for all citizens, the average age of the human life will be just increased 10 years more. One thing decadal because of the flush toilets. The flushing of the toilets is first designed in the civilization and in the subcontinent. So those things are there, but the problem is that conventional, these titanium structures, they don't have appropriate voids. In our femur, tibia, fibula, and all sorts of pectoral girdle, there are a lot of porosities in the bone structures, and they are the bone marrows are there. The bone marrows are the manufacturing place of the red blood corpuscles. So all those replacement titanium and they can give the strength, but they cannot be the hybriding place, the generating place of the bone marrow. So we have to create appropriate voids in our artificial limb. That is why people are going for those prosthetic generations, biogenerations, and all those things from the stem cell. Stem cell approach is much better than using all those part of it. So because we can generate appropriate voids, waves, and porosities, and honeycombs, and lattice structures in this very fashion. Internally embedded components. We cannot have just one component. We have to think with sensors, whatever nature has done. Every cell is a sensor. Every cell there are some kind of sensors. If you see the billions and billions and trillions of sensors are there, so even just a prick the middle, we can understand what is the position and what is the irritation on the basis of skin. So internally embedded components and sensor has to be there. So we have internally millions and millions of voids in the product, and what can be done by parts with custom non-homogeneous graded materials. It is not that always monolithic type of strategies. So we are coming from a monolithic from one protein, but it is a reformed one in one way or the other, so that we can generate all sorts of library arrays of all those proteins. I always take my students, take my listeners out of the closed chamber. That is from Tagore. Take them outside from the classroom. So Santiniketan, classrooms are open. Unless you're open, your senses are not open. Unless you take our listeners to the museums and other kind of creations, we cannot make them sustainable learning. Learning is just to inflict life into the fossils. So here, I always tell that everybody should go to Hyderabad to go to Salarjung Museum. And you can see this is the human creation. We are far away from creating these kind of features on a brittle material like rock. If you are not very far away from Hyderabad, you are in southern part, and definitely visit Veiled Rebecca of Salarjung Museum. 167 centimeter statue, and it is round pedestrian curved from a single block of marble without any joints. You see the sculpture, you see the capability of the Italian sculpture. I've seen a lot of sculptures in the Museum of Madrid, Museo Prado, where many marble sculptures are there, and one piece is here. And the Nizam has spent a lot of money in order to do that. Why it has to be seen for every manufacturing engineer, how finer details can be created. We have started with some kind of curvatures, with pulsating water jet and with the high pressure water jet, and one of the best labs in terms of water jet, it is lab of geonics, disintegration lab at Strava, Czech Republic. And we found it out. This is maybe we have to say century behind in order to do that efficiently. You can see all sorts of curvatures and other things, so that people will understand, people will confuse that it is not raw, it is just some textile. But it is done in one go with such kind of knowledge of the hardness, porosity, the material removal character, machinability of the rock, and it is done. So the life-size sculpture of Rebecca represents innocence and purity as by Giovanni Benzoni. It is an Italian name because Italian name is ended with vowels. Here you can understand pretty well that it is an Italian name and create the appearance of a transparent veil in rock. So this is the ultimate level of creation of human being on the rock solid, and today's manufacturing creating all sorts of things and material liberation maybe a century or maybe 2 centuries behind that kind of thing. So there lies the challenge of outstanding artistic tradition. You see another one. People visit Taj Mahal. People visit Taj Mahal, but in order to teach material removal rate, material removal process, machining, every student of manufacturing to visit this place. It is the intricate works of Dilwara temple. This temple curved entirely out of white marbles, built in 1031 AD. Can you imagine? Vimal Shah, the minister of Vima, and they have, what is the specialty? It is better. The curvatures and other things are better than the Taj Mahal. Taj Mahal, in order to artistic and other things, it is much better because they have removed all those things in a very tricky way. And whatever the amount of material they can remove from those things, those workers are in terms of value of powders of gold. And that is why you can have these hanging structures, and that is done in 1031 AD, ultimate level of material removal from a very, very brittle material. And that is done. What the Europeans cannot think. We have done Angkor Wat at Cambodia. We do things on marshland and these things without the European mortars and other kind of architectural system, and that's standing in marshland for 500, 600. I definitely believe, I have total belief that we are better engineers than the European. Only steam engines and few things are make us behind, but still we have the technology of high quality material removal, maybe individual, and that has to be implemented in terms of mechanization and automation. So we have to see these structures and museums to understand what can be the ultimate challenges of the material removal. You see how nature is doing that. What nature is doing? This is the clouds. What is the advantage? You can deposit calcium and you can remove the material here, so that anytime we need a tool where we the auto deposition or laser deposition, so that we cannot have to change the tool by dismantling that thing, and that takes a lot of time and wastage. So if the tool has to deposit some material and then remove the material and make it sharp, And that way, what that every animal is doing. Tiger sharpening its claws after it is getting bigger and bigger because of the autocalcium deposition places. And this is the motivation in order to bring these high featured kind of quality materials and tools in terms of manufacturing. You see another, the tribal people of Northeast, they are very clever. They make a bridge of without any penny. They are putting all those banyan leaves and let them go through just like Monshai and other things to cover these places, maybe 10 years. And they can make a living bridge at Meghalaya. So no structures and other kind of thing. Let the banyan tree decides on how they will, and consolidation by a lot of trees, and you just have to cut it out and just shape it out so that the bridges is made. Living root bridges, no water, no bridge. And people are thinking of if we can bring those bridges without any supply chain hassles, then that can be done. And this is the chemoplasty of the plants. How plants are doing it in a very clever way. They are putting all those things of scenes, and whenever there are stresses, they deposit more. And according to that, they take the curvature, and according to that, the strength. This is the ultimate example of online design. I always tell the best design is online design. If it is offline design, it's a dead design. Whenever the things will come, the design cannot take place. A bridge, if the load and other things, you cannot change its shape and other part of it. It is a dead design, it's offline design. But nature's every trees, you go outside and look beyond the windows, you will find it out the ultimate level of online design by chemonasty. They deposit all those hormones wherever the stress, they grow, and according to that, you can have a lot many infinite solutions in order to consolidate that part of it. So we have to go for hybrid additive manufacturing, maybe a gallant attempt, maybe a rudimentary attempt, maybe an infantile attempt to replicate nature in its all form. So as a result, the material composition and placement become design variables, and engineering part performance can be dramatically improved. And it can be improved even in online if you can have some kind of depositing material and removing material even in the component itself. And it might not be too ambitious to say that this technology will be the important catalyst for the next industrial revolution. Next industrial revolution will happen in Asia, I'm very sure about it. Now today's Asian economy is more than that of the economy of the rest of the world. And definitely one time India was controlling, before the British advent, is more than 30% of the world economy. One time China was contributing 50% more than that of the India and China will make the thing, and that revolution will take place definitely in China and in India, where we can have this kind of highly featured product which is comparable to the production nature. So the relevance of this provides the support for the new hybrid manufacturing technologies in which additive manufacturing, printing of metal deposition is incorporated with subtracting cutting methods in a conventional machine design. Convention as well as the deposition, that has to be appropriately, judiciously managed so that to get those products. So these manufacturing techniques will reform the way one thinks about manufacturing parts by building complex, complicated geometries, including internal cavities, voids, because the female parts are always a challenge. We make male parts and tools and then produce the female parts and conjugate it in many kind of non-traditional manufacturing processes. So internal cavities and voids and other things are a bigger challenge than the male parts. And one of the face of it, dwelling production techniques of additive and subtractive like they would be difficult to combine together. And this is the challenge, and synchronize appropriately they can offer powerful novel capabilities to manufacturing industries willing to comprehend these new manufacturing processes. So this will have the potential enable new designs, machine internal areas during build. We require self-lubricating bearing, we require self-lubricating shafts and all sorts of things with internal wires for retaining all those lubricant at the appropriate places so that it is not hungry of lubricant. We don't maintain huge amount of supply chain in order to produce, in order to deposit lubricants at every stage, tightly control tolerances during build and produce finished parts on one machine. You can see, one can appreciate the different kind of thing, deposition parts into a feature for additive and subtractive. So this is one kind of structures, and there the nozzles are fitted in one machine. So this is the first part, then the second part, third, additive, and here it is some kind of additive as well as joining. In that way, maybe a little bit of machining. And according to that, the same machining environment, these kind of highly featured component with the software control in the same machine, we can come out of these kind of parts. It is done in a single machine environment, while depositing and as well as joining, and then little bit machining, and we can come out with this part of associated with it. Just like a team, we cannot have 11 batsmen, we cannot have 11 bowlers. So the combination is 5 bowler, 5 batsmen, and 1 wicket keeper. So here maybe 50% effort for deposition, 50% effort for subtraction, and or maybe 40 and 10% effort for joining. So if you combine all sorts of features in one single machine tool, you can land up with these kind of products at the end of the day. So there are different kind of additives in the toolbars, where decompose, merge, promote, subdivide, and all sorts of things are done in the CAD environment, and subsequently it is implemented in these kind of manufacturing places in order to get these products. So one can easily find it out in process workpiece verification works for both additive and subtractive. So this is an addition.
Sir,
Once is addition, little bit of say deformation you require. So little bit of deformation, it is better sometimes, and you can do some kind of say machine also in order to have those features. You can ask that every time you can deposit. Yes, that is, but there are some issues. Their optimization time and other things will not be there, and there are some issues. So accurately, skillfully, one has to combine, just like our team. We cannot have all bowlers or all batsmen. We have the combination as and when required. Subtraction and addition will be done. And according to that, you can come out with some better featured products. Surface features can be additively applied. Surface features can be additively applied to a part that is otherwise machined. So we reduce the efforts of machining, addition, and little bit of
sir, actually,
so all those kind
of mechanical.
Like say, we are manufacturing these the typical curvature of a turbine blade. The problem with the turbine blade is that it has to withstand a high temperature and high stress. And what should be the profile? It's a 3D profile. And where the design is available? In the dolphin wings through reverse engineering. Still people are really having CFD. We're telling CFD everything is solvable. The answer is not true. Still how the dolphins have this kind of jump, or a blue whale. The weight of a blue whale is 200 to 250 tons, and half of that they can just jump from the water, half of it, and see around and come back. And on their fins and other things is a flexible one, and they can generate enormous of force and lift from there itself. It is possible because of a very typical curvature, and that is a camber. Flexible curvature. They can play with this camber just like used to roll in terms of manufacturing papers. I have worked in a paper machinery, and they are using the booster rolls in order to generate the different kind of thicknesses, so that the camber of the rolls can be changed, which cannot be changed in case of other kind of rolling mills. And only one company or two companies in this world can manufacture this booster roll. With the pressure differences, they can change the camber of the roll. So these kind of features are needed in order to generate all those things in exotic material, stigog material, difficult to machine material. We have to all sorts of things, so we have to do some kind of hybridization effect in order to generate all those things in a challenging one. And sometimes design we have to copy shamelessly from the nature, because many a time CFD cannot tell the behavior pattern of it. CFD cannot tell even the swinging behavior of all those fast deliveries, especially for the Indian. Professor, you can ask those questions in Professor Firoz Alam, who will be again a speaker there itself. Kokakura ball, you can predict it, the swing, but Indian made all those cricket balls, because their stitching and other things are so different. So every ball have a different kind of swinging capability and reverse. mechanisms and other things. And every time it is going through wear. So it's a very, very dynamic situation in order to do that. And the batsman with his huge amount of intelligence to do that. In order to make a robo which can bat like, say, Virat Kohli, maybe 200 years, 300 years, because every time he is a changing one, and you can inspect all this quality of the ball, and their shapes and other things are different types of that. So come out to these kind of feature oriented, so some parts is deposited, that's a very, very difficult decision. You will find it on machine tool, the expert people are the process planner. They know all the process and judiciously and sequentially they have to do that. So these kind of very, very difficult things, and how much will deposit, how much will add, and how much machining and other things, in what sequence has to be done, that has to be implemented in terms of software, where you have the nozzles, and sometimes you have the more than one nozzle. One is for the blunt deposition, lot of deposition, and one is the finished depositions. And according to that, and it is mounted on a CNC 5-axis machine to do that, all sorts of machining and other things as and when required, judiciously in appropriate sequence. You can see on this impeller, blade tips of a different material from the rest of the blade have been added using the additive here. You cannot have all sorts of monolithic structures because these part and the cover part will be a different material, the structure will be just like tool coating and other things should be of tungsten carbide, and in between it you have the tool steel. The reason is that if anything is made of tool steel, everything is made of all those tungsten carbide, it will be very brittle. So hybrid that is the flesh and other kind of muscle. So that kind of appropriate hybridization has to take place in order to do some kind of feature-based manufacturing process in case of these environments. So this is also one example. After the material has been added, the machine tool can swap in a milling cutter to machine those new tips flush with the rest of the blade, and that has to be done in an subtracting way after addition. And that we feature. And some machine tool actually uses two of the hybrid heads, one for quickly growing and one for frying, rough cut and finish cut. And according to that, and that has to be, and that is also a strategy. Which part is then just like adaptive slicing, just like a vendor who is supplying ice cream to a party. If he finds the line, if queue is big, he is slicing thinner. If the queue is big, small, he slices it bigger. And the strategy of the person who is frying the puri is different. If you find the queue is long, he's going for bigger and thicker puris because that will stop a lot of oil, so that people cannot consume that much. So queue is bigger, the thickness of the puri will be bigger. If the queue is thinner, the thickness of the puri is thinner. So all those vendors are also in a party, dinner party, they are also strategizing those things, and that is known as adaptive slicing. So these kind of adaptation has to be there. Which part has to be done by which type of nozzles in what rate, so that the entire cycle time is acceptable and the quality is not compromised. You can see the hybrid additives. Additive subtractive machining centers additively creating a part with the features. So this is a deposition, and then it is just maybe a simple structures, maybe a fabricated one, and the entire nozzles and other things is a depositor. If you take from others and then go for that, sometimes it is a hassle. So the entire part of the nozzles and those things is an additive one going for that. So these kind of capabilities with the lasers and other things people are thinking of. So hybrid manufacturing also combination of deep drawing and laser tool machine. The entire part is deep drawing and then additive on this part itself, maybe the same machining environment. So this is done by laser beam machining along with the deep drawing and the functional. So people are doing all sorts of things in a clever way. Now people are approaching for monolithic, so that the handles and other things are not made of a different material. The same material, some kind of notch and feature will be the door of modern day refrigerator, so that one doesn't have to assemble all sorts of things, and cycle time of assembly is getting reduced. So these kind of hybridization has to be taken care of, because in many cases in our time, the metal cutting people are always at drag us down with the people of metal forming. Now, no, they have to come closer together in order to do the manufacturing. I have spent a lot of time in the industry. I found it out whenever a fault comes, first mechanical gang will visit and they will tell it's an electrical fault. The electrical gang will come and they will tell it's a mechanical fault. Then when one shift production is lost, then GM will intervene what type of fault it is. I am not bothered about. The fault has to be addressed and we work hand in hand. So subtractive manufacturing and additive manufacturing has to work hand in hand. And that way the additive head allows the additive to be used only where needed in the making cycle. So some kind of features instead of joining and other things, because these joining sometimes a lot of issues, and if you can do all sorts of things in laser and other things in a controlled fashion, so heat affected zone and thermomechanically affected zone and other things will be very, very narrow, and for the aerospace requirements where the deposition and only when, because for aerospace people, the gravity is the biggest enemy. If 1 kg of weight is added to a space vehicle, which is going to bring some kind of rock from the surface of the moon, is equivalent to 1 kg of gold. So aerospace designer ready to spend 1 kg of gold in order to reduce 1 kg of their aerospace vehicle weight. So these kind of judicious deposition manufacturing on the same machining environment has to be done, and that is required for aerospace. Aerospace is a very relevant one, because once China and India become very comfortable in the aerospace manufacturing, what they are now approaching, then the white European dominance will be where. The future is Asia. Even the present is Asia. So if we have made all our inroads into the aerospace and dependency on the Western economy of regarding aerospace is win over by India and China, then we will see only the Asian emergence in terms of already Asia's economy is more than that of the economy of the rest of the world, and that lies in these kind of strategic manufacturing process for aerospace industries. So 3D printing with a metal deposition nozzle where we can deposit all sorts of metals, and finally it is well. So no supply chain management in terms of spare parts. Spare parts are printed, and that way we don't have to maintain. Like in my country, in my first company where I was there in 1994, I found 1 crore rupees of spare parts are there. In 1 crore by maybe today's in terms of say 100 crore or 40 crore or 50 crore spare parts unnecessary. You can print it out, so you can run in just in time or zero inventory type of situations. So there are different categorization. I have shared you the text material with all the listeners and with all the organizers. So laser beam melting, what can be the characteristic complex part, limited, and the process combination, integration, process chain, laser metal deposition, and then we can do some integration with the CNC machine, metal powder application, gas metal arc, welding and other things also with the CNC milling in one platform, and that is the categorization of the additive manufacturing strategy with the conventional methods and other parts. Depends on the thing, how we can marry the additive manufacturing with the subtractive depending on the requirements. So summary, science-enabled technology development for 5-axis hybrid additive machining center. 5-axis, you see, 5-axis machining European Union is not selling to India. They will make a copy, they will make a defense, they will make missiles. So India has to make it out, and a professor from IIT Delhi, Professor Sunil Jha, is approaching and is making and selling all those things to DRDO and IIT Delhi. Along with IIT Delhi lab, he is making it out, because 5-axis they will use European. So you have to build it out. You have to build it out. Atmanirbhar Bharat is absolutely. And if we Atmanirbhar Bharat, why we are purchasing arms from Western economies? That is not a very, very clear position. If we purchase the arms with the Western economy, then Western economy in terms of war, they will be in a advantageous position. If we purchase arms from China, how we can fight with those arms with China? They know better, because they have manufactured them. So Atmanirbhar Bharat is not an option. It is indispensable. Unless we can make our arms and ammunition by our own house, we cannot have the military supremacy. That is the end of the day. So highest investment is required in terms of R&D technology. And robotic free-form deposition systems will require some kind of control so that the degrees of freedom so that the robot can go to at any point of time and deposit the material as required. And commercialization of the technologies in the existing industrial areas. I've taken these references, and next I will show some very important slides with a professor from Finland, Professor Pedro Villaka, has sent me so that I just excite my listeners about those kind of process in terms of friction stir welding and implementing all those things in the future and very type of product. Professor Pedro Villaka is a very known professor in terms of friction stir welding and friction stir processing, and he was in fact the jury of the team for judging the PhD degree at a very old age. He is from the inventor of friction stir welding, that is Thomas Venn, working in the welding institute in the UK. So you see that caliber of person, and I am very fortunate to spend 5 weeks at Finland now. Students in regular intervals spending all sorts of things in Aalto University, Finland, and he is very kind enough to share me some of the slides. And one can see this is the additive manufacturing by welding. I will just go for this big screen, and then this is by Professor Pedro Villaka. I can establish the contact with him. I was very interested to bring him, but maybe he's a very busy person. I bring Professor Feroz Alam, but unable to bring him in your webinar. But next time, yes. So friction stir-based technology and surfacing also. We have done a few experiments on friction stir surfacing. We can surface all those things. Different kind of characteristic features we can implement on the surfaces and on the basis of that we can go for that. Function graded materials. And we can have these kind of features in many cases, very hard things. Friction stir. Advantage is that because you can put all sorts of other surfaces. And the beauty of this welding, because many of the cases the two materials are not weldable material. They are very not managed material. The difference between welding and welding, we tell that in welding we have spark and then bond forever, and welding we have bond and then spark forever. But when we have spark-based welding, another thing is that the welding point is not similar, so they are providing to be a divorce material, not marriage material. But if you do it in friction stir welding, all sorts of things are. Without going into the melting point. And you see, this is the thing I want to show to all my listeners.
Sir, right, sir. Next, so
வச்சுருந்தாங்க நேற்றே வச்சுருங்க.
Yes, sir, yes, sir. So I'm connected with the system. Yes, sir. Some problem, yes, sir. No problem, sir. participants? Any questions? Participants? Hello? Any questions from? Okay, sir. Okay.
என்னாச்சு டிஸ்கனெக்ட் ஆயிடுச்சு? ஏங்க சார் டிஸ்கனெக்ட் ஆயிடுச்சா?
கொஞ்சம் டிஸ்கனெக்ட் ஆகிடுச்சு நெட்ஒர்க்கு
அவருதா? இப்போ மறுபடியும் வரலையாட்டு இருக்கேன் இன்னும்
கொஞ்சம் கட்டாகி போச்சு. அப்புறம் என்னாச்சுன்னு சொல்லி பஸ் விட்ட
முடிஞ்சிருச்சா இல்லையா? அவர் பேசுறது கேட்குதா இல்லையா?
போயிடுச்சு.
தனியா சரி கனெக்ட் ஆகலை, இதில் ஆகலையே.